In this slide, we discuss about the input impedance and the output impedance. Don't confuse that the input impedance is a signal. The output impedance is another signal. Impedance is not signal. It is a resistive-like property. It is calculated by Ohm's law. The input impedance is equal to the voltage difference across the input divided by the input current. The output impedance is equal to the voltage difference across the output divided by the output current. Impedance is a resistive-like property used in AC circuit. Since AC circuit comes with the parameters of frequency and phase, therefore impedance is also a function of frequency and phase. We call this the resistive impedance is equal to the resistance, and the unit is ohm. The capacitive impedance is given by this formula. Omega is equal to 2 pi f, so at different frequency, we have different capacitive impedance. Why the phase is negative 90 degrees is because impedance is calculated by Ohm's law, V over I. The phase of the voltage across the capacitor lags behind the current by 90 degrees. That's why the phase is negative 90 degrees. And inductive impedance is given by this formula. The unit is ohm again. Let's discuss about distortion now. If the input signal and the output signal have the same shape, then the output signal is not distorted. Same shape means the input and the output signal has a linear relationship. However, if the output signal does not resemble to the input signal, then the output signal is distorted. Let's look at this figure. A sinusoidal signal is applied to this amplifier. A load is attached to the output. The expected output waveform is a sinusoidal waveform. This output waveform may have a different amplitude or different phase compared to the input sinusoidal waveform. But so long as they both have the same shape, then we say the output is not distorted. However, if the output waveform have a different shape compared to the input waveform, then we say the output signal is distorted. We got to understand that distorted output doesn't mean the output have to be clipped off. In fact, for this example, because the input signal is a sinusoidal signal, so long as the output signal is not a sinusoidal signal, then there is distortion at the output waveform.